welcome and thank you for watching this video. First of all, I would like to introduce myself. My name is Felix Tayai and our group members, Aiman Razin bin Muhammad Shahran, Muhammad Azard Faez bin Mazidul Akmal, Amirul Syafiq bin Rizwan, and lastly Muhammad Fikri Suhairi. So we're here today to tell you about what is our project for this assessment. Our project, we name it Welding Monitoring System Integrated with IoT. Why Welding Monitoring System Integrated with IoT? Here's why. In Malaysia, there are many types of industries such as oil and gas, automotive, palm oil, rubber and tin. The most critical industry welding is welding. It's exposed to danger that can harm human or even worse death. That's why we choose this project to help humans to work especially in manufacturing industries. In this project, the parameter measure is the voltage, temperature, wire feed, and accuracy of the welding machines. So voltage sensor have been used to measure the voltage flowing through the wire of the welding machine during use. Temperature sensor measure the temperature of the environment, followed by the wire feed sensor to detect the conductive surface of the part to be welded. Laser photoelectric sensor for the accuracy for robot weld accuracy correcting. Arduino Uno is the main controller in this project and act as a controller to receive value from sensor and send data to the IoT. ESP266 Wi-Fi module is used to connect the Arduino Uno to send data to the IoT. Once the data has been uploaded into the internet, website is used to display real-time reading of the current sensor to the user. The following explanation describes the working principle of the whole system. All principles are the same as example for the sensor to make things clear. A. The welding monitoring system is turned on and green LED will light up to indicate that the system is active. A voltage sensor will be installed on the welding station for monitoring. User access the apps to view the voltage and usage of the welding machine in real time. The red LED will illuminate if the voltage exceeds the sensor limit value. User download data in cloud or access file format is required. There are three similar systems that do not use IoT. There are manual welding monitoring, detect unusual things via manual inspection, detect heat by touching and spray water toward the item. Why the system need to be integrated with IoT? They are to ensure a smooth welding process as the welding voltage affect the arc length. To minimize budget and cost to avoid losses in profits, to minimize error on welding specimen, can help supervisor track welding work remotely or anywhere using IoT. And lastly, to increase productivity as well as increase profits. That's all from me. Thank you.
Assalamualaikum and hi, my name is Fikri Suhairi from the Bachelor's Engineering Technology in Automotive Maintenance. So I'll be covering about Chapter 2, Problem of Current System. Most of the supervisors in the oil and gas sector have found that it is difficult to monitor the work of welders because they have other responsibilities and welders typically work away from the supervisor's side. As a result, a system that can help supervisors monitor the work of welders is needed. Supervisors or other relevant personnel may monitor the running time of welding machines over internet via IoT using this technology. Furthermore, this technology can help welders complete their work on time, resulting in increased productivity of the organization where they work. Many concerns previously existed in the oil and gas business, such as lack of time, lack of money, political issues, and falling oil prices. Over time and budget surpluses can attribute to project solutions to the problem of welders not doing their jobs properly on time. As mentioned earlier, efficiency is important in every sector as it can be considered a competitive advantage in today's fast-changing market to get high yield and avoid bankruptcy. Next topic is the component involved. As for our mini project, the Internet of Things IoT is a network physical item equipped with sensors, actuators, software, electronics, and connections, allowing them to communicate and share data. IoT is a technology that allows you to send and receive sensor data over the internet. Cars, cell phones, and smartphones are example of physical devices. There are 9 main components in the creation of prototype hardware and software in this project. Each of the components is essential to the completion of project system. The main explanation would be on voltage sensor, laser photoelectric sensor, true wire sensor, and temperature sensor.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Syafiq. I'm from Welding Quality Inspection Program. So today I'm going to talk to you about the component in our machinery. So let's get through it. So today I'm going to talk to you about 4 main sensors in our machine. So first one is a laser photoelectric sensor. Second is a true wire sensor. Third is the temperature sensor, and the fourth one is the voltage sensor. So let's get through them all. First one is laser photoelectric sensor. So what is the photoelectric sensor? So basically photoelectric sensor is basic use of a laser sensor is non-contact out of 2 until 5 times faster option on touching sense as most of the robot motion required is eliminated to acquire the part of location. Instead of physical wire touch to part, a laser dot and sensor capture the location and oriental of a part as quickly as a laser fires. While it is still easy to teach and required a touch monitor sensor, and like touch sense, it cannot find a square butt joint and cannot potentially run into issue with a highly reflective surface. However, it eliminates the need for wire cutter and wire braid. It can delete lap joints down to 1 and 16 inches thick. For the second sensor is a true wire sensor. So what is a true wire sensor? True wire sensor is a touch sense. Sometimes it's referred as a wire touch. It is a physical touch of a weld wire from the end of the touch to detect the conductive surface of a part to be weld. The system uses a low voltage circuit during a low speed search to detect the weld joint. Although there is no hardware mount on the robot, a wire cutter and wire braid for consistent accuracy seeing is required. Touch sense can be completed through built-in feature on welding power supply design for automation, but it has been proven to have the best speed and accuracy with a spare dedication circuit like the Yawasaka brand Touch Sense package. This process is slower than laser technology, as one must wait for the robot to physically move to detect the location and then slowly approach the spot for the best accuracy. Third one is a temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and converts the input data into electrical data to record, monitor, or signal temperature change. There are many different types of temperature sensors. Some temperature sensors require direct contact with the physical object that is being monitored. For example, like contact temperature sensor, while others indirectly measure temperature of an object from far away. The last one is a voltage sensor. Voltage sensors are an important part of the electrical system because they can be used to monitor, measure, and determine the supply voltage of DC or AC system. Apart from simple voltage measurement, voltage sensors are also used for power failure detection, load deflection, safety switch, temperature control, power demanding control, and fault detection. The inputs connect to the voltage sensor are usually the voltage from the system, while the output can be various types of signal form. This signal form include analog voltage, analog current, audible signal, switch, frequency, and even frequency modulated output. In addition, some voltage sensor can also perform +1 modulation, amplitude modulation, or frequency modulation. This produce a sine or plus train as an output. The working principle of a voltage sensor is usually based on a voltage divider. There are two common types of voltage sensor, namely capital type voltage sensor and the resistor type voltage sensor. After the involvement of the component, it will flow through with software involvement. So let's get through it. And device that we're gonna use in our machine is the AMV 3500 Well Check AMV. It is portable, compact model, and a robust machine for the monitoring of the current, voltage, speed of feeding, transverse velocity, temperature, and electric welding gas flow. Welding information is present in a liquid crystal display. This unit is auto-calibrate and provide protection of the tension and high frequency, and is also compatible with the weld validation software. Okay, meanwhile, the overall system flow diagram is to observe the welding station remotely. Supervisor access to the website via mobile phone or personal computer with internet access using Uniform Resource Locator or URL. As the data had been uploaded to the cloud, in the monitoring page, he or she can monitor the real lifetime monitoring work by viewing the welding status in the digit from 1 and 0. A value of 1, it means that the welder is welding, and 0 means the welder is not doing any welding work. In addition, the user can also observe the voltage of the welding machine to ensure that the voltage is in the proper range. System user can also export previous login data from all welding work by downloading the comma separation value or CSV in a file in Microsoft Excel format for future analysis. After monitoring is done, the sensor is disconnected from or removed from the welding machine. You can see in the comma separated value or CSV file is a circuit diagram was built and developed prior to the prototype creation to ensure the system smoothly developed. This is because throughout the development phase, a circuit diagram serves as a reference for the user. A secret design can assist prevent incorrect wiring, which can produce a short circuit or break the electrical component due to lack of concentration or human error. WeldCheck software, an open source tools for designing electronic circuit, was used to generate the circuit diagram. So there are 3 LED utilized in the circuit diagram design, which are green, blue, and red. The green LED, which was used to show that the system was turned on, is powered by the Arduino Uno at 3.3 volt and shielded with 100 ohms to prevent the LED from overheating. In the meantime, the blue and red LED were connected to Arduino Uno digital pin 8 and 9 and protected with 220 ohms resistor. On the Arduino Uno, The ESP8266 Wi-Fi module was connected to digital pin 2, digital pin 3 and 5-volt power supply, and grounded via the ESP-01 adapter. Because the connection is based on the serial communication with Arduino Uno, the digital pin were used for the Wi-Fi module.
Assalamualaikum and hi, my name is Azard Faez. I'm from UniKL. Today I would like to present about chapter 2. 2.4 Process and Activities. First of all, getting ready the specimen. Then start welding process. Sensor will start to detect specimen and monitoring camera start to detect specimen. Weld check software will start to read data and monitor current, voltage, speed of feeding, transverse velocity, temperature and gas flow. Weld check will feed data to user phone, and finally user can start monitor through the Hypertech app. For 2.5 user interface, Hypertech is an app created to monitor welding process through phone. It is linked with the weld check software so that user will get live information on the monitoring. In the app, there is a few functionality such as live streaming for the welding process, and it also equipped with some meters such as current, volt, gas, temperature, feeding speed, and a graph for transverse velocity. Finally, for 2.6 proposed design, two components, namely the smart device and hardware of welding monitoring system, are essential. User need to connect to the internet via smart device such as smartphone or laptop to monitor the activities. It also can be observed by LED indicators to show the system states such as power status green LED, welding status blue LED, and over voltage alarm red LED. That's all for my part. Thank you.
Assalamualaikum, my name is Amirul Syafiq and I'm from Iraq. I would like to present about chapter 3, 3.1 Advantage of the system. The welding condition monitoring system detect abnormal welding conditions using electrical signal. The welding pool shape monitoring system evaluate the position between the welding pool, electrode, wires and groove using a camera and a charge coupling device, which is CCD filter. The welding bit shape visualization system detect abnormal bit surface conditions using 3-dimensional 3D visual technique. The internal detect visualization system was achieved using test technique in laser ultrasonic process, with its short form is LUT, and focus aperture synthesis technique SAFT. Each subsystem inform workers of inappropriate welding conditions to allow them to recreate appropriate condition. Which is the first point is, with the implementation of IoT into welding, we can monitor the consumption of current and voltage used during the welding process. The second one is, all data will be backed up into the cloud, avoiding misinformation. The third point is optimize for systematic real-time data management. The fourth point is the amount of heat input can be calculated automatically after each welding session. The last one-click report production. The next one is business opportunity to the market. The heavy engineering segment is expected to grow exponentially over the forecast period owing to the introduction of smart factories, Industry 4.0, rising automation and others. Moreover, high demand for precision welding is widening, mainly for joining two different metals without losing their properties, which is further supplementing the welding industry growth. With this monitoring system applied to every manufacturing plant out there, we can reduce losses and recoup capital gains. This product will open up more opportunities to more employees out there. Previously, many welders had to have very specialized experience before a company could hire them. With this machine, we can help all new welders and veteran welders in various ways with this new method. So for the last one is 3.3, target user and customer. Welding monitoring system with IoT application are focused primarily on new welders trying to venture into this industry. Many companies out there are looking for new employees. With this machine, we can be and assist all new welders in guiding them to become highly efficient welders. Furthermore, this machine can also be installed in every welding academy. With the advantage provided by this machine, we can teach all students who want to venture into the field of welding with the help of safety. This machine will teach students to read voltage accurately. The machine will also tell students about the number of rights used and the waste. With this, we can teach students about how to be an excellent welder with a lot of information. Imagine there are new games on the market. With the gaming industry nowadays, they will teach using tutorial before actually asking us to play the game. Imagine this machine is one of the aids given to the player. Even if they are very expert player, they still need to use help because they are not familiar with the environment. Due to the help provided by the game, players are able to master the game faster and faster. Thank you very much. That's all for me.
And as for conclusion, the platform has been designed with aim providing users with information about the application of one or more system components and to support them in making decisions arising from it. Regarding task planning management, it can be easily extended and adapted to various production processes based on the test performed on the system. The prototype can function as expected. The welding station monitoring system can detect welding usage, measure welding voltage value, and send data to the IoT for monitoring. The BISA module is used to measure the welding machine reading, and the Arduino Uno is used to process the data sent to the IoT via the ESP8266 Wi-Fi module. Therefore, user can also interpret the data and monitor the data directly using the website or apps. However, small drift in accuracy are expected when using the system due to external factors such as application variables, lack of proper installation, and natural drift should be taken into account while using the system. In short, the supervisors can use the system to monitor the welding work, which has been proven to increase the productivity of the welding work in the industry, as it can help ease the monitoring work done by supervisor. That is all from us. Thank you.